In this video, we're going to talk about the insertion sort algorithm. If you haven't yet, go have a look at the other video where we spoke about the bubble sort algorithm. Insertion sort is another sorting algorithm that is perhaps not quite as easy to understand as bubble sort. Still very easy though, and it's also incredibly easy to implement. To explain how insertion sort works, I have here a little list of numbers, and we're going to sort these. And first, let me explain how it works. So what we're doing is we're starting on the left and we're building a list of sorted numbers, not a separate list. It's actually part of this list. But these numbers become part of a sorted list. And the way we do that is we start with a single number, which is our list. Then we keep successively adding numbers from the right. And we're going to move those left into the list, effectively inserting them into the list of sorted numbers, which is where the algorithm gets its name from. Now, as we do that, the list keeps growing until it finally includes all the numbers from our original list, except that now they're sorted. So let's see how this works. So my initial list is just a single number containing the 4. Now I look to the next number, which is the 1, and I'm going to add it to the list. And to do that, I'm going to move it to the left as long as there are bigger numbers. So the 1 is smaller than the 4, so I have to swap these two numbers to move the 1 to the left. And I can't move the left any further, so it's in the right place, and so is the 4. And now our list has grown to 2 elements. Now I look at the next number, and that's the 5, and it's already bigger than the 4, so I can't move it to the left. So our list of sorted numbers now contains 3 elements. Then I look at the 2. The 2 is smaller than the 5, so let's swap them. And it's also smaller than the 4. Whoops, what have I done here? Let's swap those. However, the 2 is bigger than the 1, so now we know that the 2 is in the right place. And you'll see, as we keep swapping these numbers, that the bigger numbers automatically end up on the right. Now our list has grown to 4 elements. We look at the next number after the list, which is the 6. The 6 is bigger than the 5, so we can't move that to the left. So we see our list has grown to 5 numbers, and now there's only one number left, which is the 3. So the 3 is smaller than the 6, we swap those two. The 3 is also smaller than the 5, we swap them. The 3 is also smaller than the 4, but it is also bigger than the 2. So now we know that it is in the right place. And you see how very neatly everything has ended up sorted. The bigger numbers on the right, smaller numbers on the left. And now we've reached the end of our original list, and we have a sorted list of numbers. Now let's look at how we would implement this in code. And here I've already got a complete Java example. I'm going to talk you through the code, and then we'll look at what it's actually doing visually. So for now, you can ignore this main method. It's just there to test our sorting method, which you'll see here below. The method is called sort, and it's taking in a list of numbers as an array of ints. Now, as if you watched the other video, you'll remember I said we don't only need to sort numbers, we can sort any values that can be compared where one number is bigger or one value is bigger than the other. But to keep things simple, we'll just focus on the examples with numbers. Now inside our method, we've got an outer and an inner loop. So this is called a nested loop. And what it will do effectively is that for every step of the outer loop, the whole inner loop is going to run through. And once that's finished, it's going back to the outer loop. The outer loop defines a variable called I, and this is now pointing into our array of numbers, and we're going to go through not from the first element but from the second element, and you'll see in a moment why that is. And it will carry on until it reaches the end. So in other words, while I is less than the length, and then obviously we have our increment operator. In the inner loop, we're declaring a variable called j, which is also pointing into our list of numbers, and it starts off being equal to I. But now from where I is, it's going to go backwards to the start of our list of numbers. So in other words, it's going to execute, well, it's going to go backwards. We're going to decrement it on each turn, and it is going to go back until the second element. Again, we'll see why that is in a moment. Inside that loop, we're going to say that if the number that is pointed to by the variable j in our list is less than the number, well, we'll say to the left of it, next to it, which is in the list of numbers that we've sorted, then we're going to move it into that list. We're going to insert it, and to do that, we're going to keep swapping it with the number next to it until it reaches the right place. So only while the number next to it or to the left of it is smaller than the number pointed to by j, we're going to swap it. And to do that, we're using a temporary variable which receives the number pointed to by j. Then j is being set to the number next to it. And finally, we're going to put the number that we stored into the temp variable into the number next to it, into j minus 1. Right, let's see how this works in practice. Here we now have a visual example. It's an array of 5 numbers, and the row below is the index. So remember that we're counting from 0. So 0 is the first index, 1 is the second, and so on. And like we said, I is going to start by pointing at the first number. And the reason we're starting there is that our first number in the list is already part of our sorted list. And I'm going to color that yellow so we can follow and see which numbers are sorted. So I is then pointing at the next number that we want to insert into our list. So we've set I here. Now we're going to the inner loop. J is first being set to I. And on the first occurrence, or the first time that we run through it, j can't go any further. We said that it's only going to run for as long as j is bigger than 0. So the first time around, it will only start and stop here. Right, now let's look at the number pointed to by j. It's 5, and we're comparing it with the number pointed to by j minus 1, which is 6. Now because 5 is smaller, like we said, we have to swap the two, effectively moving 5 down. And at this point, we now have 2 sorted numbers in our list. So let's color that so we can see that that's what our list looks like. And the inner loop exits after the first step, and we're back in the outer loop. In the outer loop, we're now moving to the next number, which is the number 2. And we immediately go into the inner loop, where we are pointing to the number 2 and going through the same checks, where we see, is the number smaller than the number to the left of it? Yes, it is. So we swap the two. And now we move j down because we're going to the next step of our inner loop. And we do the same check. Do we have to swap them again? Is 2 less than 5? Yes, it is. Let's swap them. Right. And now we end there because j can't go left any further. Right. And let's again color this. So this is what our list looks like. And as you see, it gets increasingly bigger, and the nice thing is as we move the lower numbers down, the bigger numbers are automatically being pushed to the right. Good, we're back in the outer loop. I now points to 4, and you can kind of see where this is going. So 4 is smaller than 6. Whoops, wait, let's move it across. Also moving j down. 4 is also smaller than 5. We're moving j down again. 4 is, however, bigger than 2, so no swap happens here. So we stop there. Let's color that and move on to our last number, the number 3. All right, and now we just need to insert the number 3 into our list and we're done. Okay, so let's move it across because it's smaller. Is it still smaller than the next number? Yes, it is. J goes down again. It's still smaller. Right. Now, it's at the right place. No more swap needs to be done. The enhancement, or the little 2 extra lines that I wanted to add to the code, will do a check for us. If at any point we find that j, the number pointed to by j, is bigger than or equal to the number next to it, then we can actually stop. And let's look at that in the code quickly. And before we do that, let's just color this as well. Right, we've finished going through the whole set, and you see the numbers are sorted. Back in our code, like we just said, if at any point the number, while we're busy swapping the number to insert it into our list of sorted numbers, if we find that the number next to it, which is j minus 1, or j minus 1 is pointing to, is less than or equal to the number that we've got, then we can actually exit the loop. That'll save us maybe a bit of time while we're going through it. So let's just put a break in here. And then we don't have to go any further. Right, so even without this, the algorithm would have worked, but it just makes it a bit more efficient if we break out early once we realize that the number is in the right spot. Good, let's run this through once and see what happens. Okay, so it's taken the list of numbers that we've passed. We've just declared a list of numbers here. We've called our sort method with it, and we've output the result. And that's the result you see at the bottom here. And it seems to be working. Well, I hope that made sense. If anything was unclear, let me know in the comments below, and I can see if I can try explain it better.